Hi, and welcome everyone to this webinar on maximizing your seawater reverse osmosis energy efficiency. This webinar is hosted by Danfoss High Pressure Pumps. Today, my colleague Javier Lorenzo, the Technical Sales Manager, and I, Amogh Sharma, Application Marketing Manager, will be your host. Danfoss is a major company based in Denmark with sales and service over 100 countries. We at Danfoss strive to be our customers' leading technology partner in green transition. We invest heavily in R&D to help our customers become more energy efficient. The high pressure pumps division focuses on energy efficient high pressure pumps and energy recovery devices. And almost 50% of our sales goes to SWRO industry. But we also have solutions for other applications such as firefighting, marine applications. Water demand has been increasing for a while, and this trend is expected to grow and continue due to rapid industrialization, accounting to 21% of the demand, growing population, accounting to 10% of global demand, and increased agriculture, accounting to 70% of global water demand. You might wonder, do we have enough water resources to meet the supply? Well, we do have plenty of water around us, but of this, 97% is seawater, and fresh water accounts to only 1%, resulting in water scarcity, which has been aggravating because of groundwater depletion due to overuse, climate change causing changes in precipitation patterns, and extreme weather events such as hurricanes. This leaves us with only one option: desalination. Compared to other sources of fresh water, desalination is the most energy intensive. On an average, the specific energy consumption is approximately 3.65. Well, you might wonder, what is specific energy consumption? It is the amount of energy used to produce 1 cubic meter or 1,000 liters of water. It describes the energy intensity of the entire system and not just the individual components of an RO or SWRO system. Evolution of desalination has been simple yet exponential, from condensing the steam in a pot at home or boiling pot to thermal desalination that used almost 27 kilowatt hour per cubic meter, osmosis, which we use today, which has a specific energy consumption ranging from 1.85 to 5 kilowatt hour per cubic meter using isobaric energy recovery devices. However, many of the SWRO plants that are built today are not don't include isobaric energy recovery devices. Here is a brief overview of an SWRO plant. The seawater goes through a pre-treatment via a high pressure pump into the RO process, and as an output, you get fresh water, which is further post-treated to the reject water, that is brine, is the concentrate of high salinity. On the right hand side, you see how the amount of energy consumption is spread across the intake, from intake to distribution. The high pressure pumps in an SWRO unit accounts for 70% of the energy consumption. Using an ERD, that is an energy recovery device, will help you make use of the high pressure that remains in the brine after the seawater has passed through the membrane. By reducing how much energy the high pressure pump needs to use, the ERD in overall can save about 60% of the specific energy consumption. But yeah, here as I mentioned that an energy recovery device can reduce 60% of specific energy consumption. So the question, are you using an isobaric energy recovery device today in your systems?
Yeah, I think it's more and more usual that the people is using ERDs in the system. I mean, and that's why the rate of it exists nowadays in more and more plants. So yeah, I think it's the most common way, at least to save energy. Relevant because we are entering. I mean, we are discussing a lot in the different exhibitions about savings, about efficiency, about this water positive trend that we have in the market, and it's quite strange that people or desalination plants is not using any recovery device to recover the energy from the membranes.
Well, it's a surprise, Javier. Most of the people don't use.
Yeah, I mean,
at least
we did some webinar in the early morning. Yeah. We did the same webinar in the early morning with the same question. And in that case was around 60% of the audience was not using the ERD, but now we have 100. So yeah, okay, good. So I will take it from here. So let me explain about different devices. This is not an energy recovery device. It's the axial piston pumps. Is what the Danfoss HPP has in our portfolio. We are not producing or working with the centrifugal pumps. And why? Is because we just believe that the efficiency that we can deliver with the axial piston pumps is much higher than the efficiency that we can get from the centrifugal pumps. And as you can see on the graph on this slide, I mean, the lowest the capacity, the highest the gap efficiency that we can have between the centrifugal pump and the axial piston pumps. So it seems to be quite obvious that the technology, if you want to save energy or you want to be more efficient on your plant, is to go with an axial piston pumps. But it's something that so many people, so many customers don't know about this technology that in Danfoss we were using for almost 50 years in the divisions, in different divisions. So yep. So one thing that I would like to highlight before to move to the next slide is that the axial piston pumps is a technology that we are not depending the efficiency because of the flow or the pressure. We can deliver the same amount of flow regardless of pressure, and the efficiency will remain the same in the whole range of operation. And this is quite important, as you will see in the next slides, because basically when we are operating in a plant, in a desalination plant, we can have different scenarios in terms of different pressure, different water demands. And if you combine all together, you will see that we have different environments and different conditions. And we need to adapt in a better way with the new technologies. So what I was talking about is about these different variations. We can have different water demand variation during the year. As you can see in desalination plants, if we look in a desalination plant that is running, let's say in the coast, normally during summertime is where we are going to have more water demand, right? And during this winter time, we will have less water demand. So we need to be flexible enough to adapt to these water demands, but also to this change of pressure. You see that then during summertime also the temperature will increase, and therefore the pressure that we will have on the membranes will be less or will be decreased in compare winter time. So if we compare both scenarios, you will see that we are not designing most of the cases. We are not designing the plan in a good way, because basically we have a really stationary design where we are designing for just a couple of duty points or one best scenario, and that's why then when we start operating the plant in a real life, we can have a lot of wasting energy. On the right hand side of the slide, you see how it looks like the centrifugal pump. Normally you design for this best efficiency point. So this is the best scenario possible. And this is normally the gap in efficiency that the customer is taking to analyze all these power consumption savings and payback time during the whole life of the desalination plant. But the reality is far away from this. We will see that as soon as you start entering in these systems or these scenarios, the water demand variations, pressure variations, temperature variations, you will see that we are operating far away from this best efficiency point. And as soon as we start operating far away from this best efficiency point, the gap in efficiency start being more and more relevant. So we need to be sure, or we need to take into account all these considerations. Just a couple of points. Basically, what I mentioned in the previous slides, flow and pressure in case of the centrifugal pump is totally correlated. So we need to be sure what are the duty points that we are gonna operate in this case. On the other hand, positive displacement pumps or axial piston pumps, doesn't matter if you are running with different flows, different pressure, the efficiency that we can deliver in the whole range of operation will remain the same. So it's not correlated the flow or the pressure that we have in the system. If we talk about the energy loss due to friction, in case of the centrifugal pump, there is energy loss due to friction, but there is no any energy losses that we can have on the axial piston pumps. If we talk about nominal efficiency rate, in the case of centrifugal pump, we are moving in the range of between 70 to 83%. But if we look into the axial piston pump technology, you will see that it's quite common to have between 87 to 92% efficiency. So as you see, the higher efficiency that we can deliver with this new technology is quite relevant if you want to save money in your plant. And the last but not least, actual efficiency rate. In the case of centrifugal pump is variable. As explained before, we have different scenarios. But in the case of the axial piston pump, is totally consistent. Basically, we can design for the maximum efficiency, regardless of flow and pressure variables, and the efficiency will remain constant.
So, well, in this case, or scenario, the system that we have assumed is to be working at a fixed flow, pressure, and electricity price. And considering that the centrifugal pump is able to achieve its best efficiency in emissions, the amount of savings in emission or CO2 emissions could be equivalent to 20 trips around the world by plane. And in terms of money, one could save up to €500,000 in 10 years. And that's a lot of money. Well, and situation where we are which we see with different variation in electricity prices, production demand, and varying pressure, as Javier, my colleague, also mentioned. In that case scenario, axial piston pump is ultra flexible and will benefit the efficiency and the energy consumption, or the price and the savings as well, enabling you to save CO2 emissions equivalent to up to 25 trips around the world by plane, and up to €700,000 in 10 years. And this brings us to our next poll. Are you using an axial piston pump today? What do you think, Javier? Are they?
Yeah, let's give first of all a couple of seconds for the audience here to respond. But yeah, I mean, what I'm noticed during these last years is that so many people is not using the axial piston pump. They don't even know the technology. So, and that's why this webinar is more and more relevant, and it makes more sense.
Yeah, and especially in the regions where with this electricity prices becoming increasingly expensive. Yeah, and if the electricity price is becoming so expensive, this requires even more energy efficient solutions for just how we try to have energy efficient solutions at our home, for example. I think.
Mm-hmm. Should we move forward?
Yeah.
Okay, 60% no, and 40% is using an axial piston pumps. Okay, it was good to know. This morning was 50-50. Yes, so quite similar.
Yeah.
Okay, so the next section of the webinar is to show you a real case, a real plant that we have on the island. Basically, we will show you some challenge and some solutions in this seawater desalination. And this is based on the hotel industry that we have in Canary Island. As you know, in Canary Island, there is plenty of different hotels, and the scarcity, the lack of water is quite relevant in this region, in these islands. So, and that's why this is one of the, let's say, one of the main locations for desalination in Spain. In this case story, we will work together with TAWA. Only to give you some background about the company, TAWA is a company with over 30 years of experience in the water industry. And the challenge in this specific case is, as you all know, it is energy intensive process that we need in desalination to dissolve salt in the seawater. And we offer to TAWA basically from the beginning. It was really close work. We designed and installed all the equipment on site, and this led to 50% energy savings in this case. So let us show you how it looks like the previous technology, the one that they were running in the plant, and the one that we already installed. In all days, they were using turbocharger. Basically, the turbocharger is a configuration where the turbocharger is giving you the amount of pressure that is needed from the membrane. So first of all, the whole flow of the membrane up to certain pressure, and then the remaining pressure is gonna be given by the turbocharger. So in that case, you are saving energy because the high pressure pump don't need to deliver the whole amount of pressure on the system. On the other hand, the new technology or the new configuration that is about isobaric pressure exchanger, what we are saving energy is by pumping less flow by the high pressure pump. It's important to highlight that the high pressure pump is having around 60% of the total energy consumption of the plant. So it's quite important to reduce as much as possible the energy that we need to deliver or that we need to pump with the high pressure pump. So in this sense, the recovery device is more and more relevant because we can, let's say it this way, we can reduce by half the amount of flow that we need to deliver with the high pressure pump. And by doing that, we will reduce in a much efficient way the energy consumption that we need in these kind of plants. So this is a 500 CMD plant. That was the equipment that we replaced already in the plant. You see how difficult it was just to and do the maintenance. The service was a nightmare, a total nightmare. I mean, you don't have enough space between the equipment and the train. And what we install is a much solution. We were using an APP 22 and ISA 40, and sorry, I said 21. one, if I'm not mistaken. And what we are offering is a much simple design. All the connection is made of these flexible hoses that you can see on the screen, and this allows you to connect in a very easy way and to have this connection to the manifolds much easier than before. So again, the old plan, only to give you some of the figures, the specific energy consumption was around 4.48 kilowatts hour cubic meters hour. And what we got from the installation and the new configuration was below 2 kilowatts hour per cubic meters hour. That is a really, really good value nowadays. So again, this is how we compare two technologies, the turbocharger technologies configuration against isobatic technologies. So basically, all in all, you can see that how much savings we can get from these two different configurations. And something that probably most of you is asking is, okay, and what about the investment? I mean, it's expensive to install this kind of equipment, and how looks like the payback time? So in this case, in this case story, the payback time was around 2 years, and the saving that we got than €500,000. So you can see that the basically to do some kind of investment in a new technology lead in a more savings in the future. So it's obvious. I mean, if you look just at the savings figures, seems quite obvious that which is the way that we should go in the future. And the last part from my side is just to tell you about how it looks like the axial piston pump. As you saw, it's a really simple operation. We have a bare minimum internal pumps. We have the pistons, we have the source plate, and we have some other benefits that, like, for example, we are not using oil for lubrication. We are lubricating all the internal parts by the same media. In this case, it's the water. And this is quite easy installation. The maintenance can be done on site. That is quite important. And we are training in all the plants, or most of the plants, we can train the people so they can do it by themselves, all the maintenance and service that is needed. And obviously, this equipment is quite, let's say, fits quite well on desalination plants on islands, on hotels, and so on, because of the compact design. The footprint that we need, as you saw on these pictures before, is quite small, and we can save also a space between the trains to do all the service and operation that we need. To finish, I mean, as I said before, it's never too late to start saving energy. So the first thing that you need to do is calculate all the potential savings, add the EADs, as you saw before during the webinars, and select the right high pressure pump. It's obvious that with the axial piston pump, we will say that we are on the A level. And obviously, depending on the technology, if we talk about the reverse osmosis desalination configuration, we will be around C or D level. So it's obvious that all of us will want to be on the A level. So there is only one way, that is basically buy or go with the best efficient pumps and EADs. You can take it.
No. So yeah, we if you want to have any questions or reach out to our sales, here are the people responsible for your regions. In North America, we have Darren Williams, Mr. Holmesy in Middle East, OJ in Asia Pacific, Mr. Claudio in South Europe, and Radia. So please, if you have any queries, questions, or would like to get to know more about our solutions and products, please feel free to reach out to any of these, or Javier and me.
Thank you.
Yeah. So are there any questions? We'll be happy to address them. I think there are two questions. I I can see in the chat, Javier. Yeah, I can take the first one. How much of the total cost of ownership is related to energy? Uh, well, the total cost of ownership is a mix of both capital expense and operating expense. Uh, but in the case of SWRO plant, uh, OPEX um, almost contributes to 65% of the total cost of energy, and of that, almost 55% is by the electrical consumption. And whereas in terms of capex, the pumps are even yeah uh, just, I would say, 3% of the total capex. So yes, in a way, TCO, or the total cost of ownership, is directly relevant, uh, but it varies from system design and conditions. However, in any case, you will be saving with the energy efficient pumps. If you have an energy efficient components in your system, one would be saving up to 40-50% of OPEX, and that's quite a lot.
We have a couple of more questions.
Yeah.
Amogh. Yeah, I mean, next one is, how long do you expect the payback time of an investment? I mean, it depends so much on the size of the train and so on. Electricity cost. We know that on the island the electricity cost is quite high, so the payback time will be less. But all in all, I mean, the case story was showing you 2 years of payback time, but we can say that we are in a range of between 1 and 3. This is more or less where we are nowadays. Okay, good. So if there is no other questions, I mean, you can reach us at any time. So please do not hesitate to contact us whatever you need. And thank you again for your time. Amogh, if you want to say something else.
No, yeah, thank you so much once again. And if you have any questions or want to know more about our products, solutions, please reach out to our sales in your local in your region, and please feel free to reach out to Javier or me if you have any other questions about the webinar or something else related to seawater RO. And yeah, we'll be always here to answer questions. Thank you so much.